let's wait for 30 seconds so that everyone can come back. So this can be every 40 minutes goes off. Let's wait for more people to log in. We can continue from where we stopped. All right, so we have more people coming in. Okay, let's continue. We have like 15, 16 students that logged in. So I don't want them to miss from where we stopped. So I think this is a fair number. Okay, let's go back from where we stopped. So obvious, that's why I keep saying take notes, because this on and off can be annoying. So, but we have our x-intercept. We have calculated it already.
And the y-intercept.
So we had what? Something like 11/4, or which translate into 2.75 in terms of decimals.
2.75.
You know, so the y there. And remember, this x-intercept is also a solution to this linear equation. So we have y-intercept. So these are just like a refresher. I think you must have seen this, you know, in high school. So the real thing will come when we start even quadratic. Some of us have seen it. So the real thing is when we start differentiation, that is derivatives. Some people call it calculus. So you must have had the name before. So with y-intercept, we said when x equals to 0, then y should be something like 11/3, and that's translating to 3.67. So obviously, even this and this, they are all solutions to linear equation. You understand? So now we will draw our graph here, and we have a graph. A nice graph. This time my graph is nice. We have the, as usual, y-axis, and then we have x-axis here. So what we will do, you know, we look at the intercept. We start with x, of course. Let's not forget our units. It depends on you. You know, you have to look at the values here, and based on that, you draw the units. So we have 1, then we have 2, we have 3, we have 4, and it can extend up to positive infinity, because this is a number line. It can go up to whatever, depending on the units you want to plot. So we have, then here, this can also be -1, even though we might not need it for this problem, this exercise. And we have -3. So here we have 1. Then we have, let's say, 2. For the demonstration's sake, I will put everything intact. Then here we have 1, 2, 3. This is our rectangular coordinates on a plane surface geometry. I think most of us, we have done geometry in high school. So now let's try to plot this x-intercept. So x-intercept here, it says that when y is 0, or when x is 2.75, y is 0. And if y is 0 at where? This is the origin. This is where x and y are all 0. So y is 0, then x will be something around, yes? Yes? You can go on, please. We are listening.
You didn't the point of origin. I think 0 should be there.
Yeah, it doesn't matter much to put, you know, space. Of course, here is 0, 0. It's where, you know, you have 0 here. but I assume that everyone knows this, something like that.
Yeah.
You know, but it's good. You know, thanks for calling it out. So that's the origin, as he said, should be 0, and this 0, it belongs to both x and y. It's where the two, you know, because if you looked at this in real analysis, it's where we call it +2, but that's for mathematics, those doing majors in mathematics. So because the 2 there is representing the x and the y number line. But here, as he said, this is 0, and here at this origin, y is 0 and x is 0. So to continue plotting our x-intercept, we have this. Remember, this is x coordinates, and this is y. Y is 0 here, while x is 2.75, which will approximately, I believe, will be here. So if you look at x-intercept, is nothing but it's a point whereby the line of the graph crosses the x-axis. So if we go to y-intercept, x is 0 here, and y is what, 3.67, which I believe will be around here. So these 2 points here and here, we will use it to connect the 2 points. So we looked at it here. So we just connect these 2 points. I hope my lines will not be horrible. Let me try. So something like that. Actually, it should be a straight line like this. So this point is the y-intercept. And this point is the x-intercept. So when we talk about x-intercept, it's a point whereby y equals to 0, or it's a point whereby the graph crosses the x-axis. So here, the coordinates are what? 0 and 3.67. And this coordinate here is a solution to this equation. So here the coordinates is what? 2.75, 0. So here also there are infinitely many points here that will make this, where is the graph itself? It's what, 4x. This is the graph, which is 4x. 4x plus 3y equals to 11. So here we can have many other points as well. So there could be many, and every point on this graph is a solution to this linear equation, as long as the point is here. For example, we can look for another point, because we have this point here, which is y-intercept. We have another point here, which is x-intercept. But between these 2 points, we can have infinitely many other points. For example, we have this, this is the equation, 4x plus 3y equals to 11. So if you want to find the solution, as what we did before, we can even ask ourselves, if x equals to 1, what will be the value of y? So here we substitute x for 1 in this equation. So it will be 4 times 1 plus 3y equals to 11. So at the end of the day, we'll have something like 4 plus 3y. So at the end of the day, we'll have 7 we will have 7 divided by, this will be 11. So we have to move the 4 to this side. Obviously it's plus, so it will change signs if we are moving it. So this will be 3y, 11 minus 4. So we will have something like that. I don't want to jump any step for the benefit of everyone. Some people, yes, they are grounded, but we are coming from different places. So this will be 7. So we divide both sides by 3. So that will give us what? Y equals to 2.3 in decimal, as most people prefer it, 2.33. So it will be 7 divided by 3. So this, when x equals to 1, y will be what? 2.33. So we have this here, x is this. So y, so it will be something like this. Obviously, this is not a graph paper, so we have to accommodate. So we will have a combination like this and this. So we'll have a point here, this point. So this point will be x equals to 1 and y equals to 2.33. So if you take this point here, 1 as x and y as 2.33, you substitute it here to give you 11 to prove it. So what we are trying to say, for a solution to a linear equation, any point that lies on this graph or this line is a solution to this linear equation. So in another word, we can have many solutions to linear equations. So we stop here for today. I think we have covered a lot. I will try to send you materials, and I'm not making a firm commitment, but there is a likelihood that I will make this video available to you, but I will upload it on YouTube. Not a firm commitment yet, but I will find a ways to make this video available to you people as well. So if you have a question, a comment, or you want to make a contribution related to this class, the floor is open. Or if there is any suggestion that you want that can make the class, the quality of the lectures to be better next time, the floor is open. We can have an open conversation. I want this class to be interactive. Okay, so the floor is open. Silence means what? In high school, what do you realize, or even in primary school? Everything is well understood, or what?
Well, understanding.
Huh?
Yeah.
We can talk, and if you have questions related to this course, and also I like to get feedbacks from students. The goal here is to make sure that the next lecture is better than the others in terms of quality and orders. If you think that I can twist or add one or two, you can write to me. You can first, I will, for the benefit of everyone, you can share it with everyone here. If you prefer writing to me, no problem as well in WhatsApp or something like that. It's hard for me to respond. I have a busy schedule, but I always get back to people. It might take some hours or even a day, but you can write to me related to the class always, and that's it. If we don't have any other things, I can just talk briefly on a simultaneous equation or system of equation, then we can call it a day here. But let's make the class interactive. I believe that we all have one or two things someone can learn from. Okay, nobody wants to talk. So I think we almost achieved what we set the target. Those who have started the class with us, we said that we want to cover the following things. We talked about, let's make a recap of what we have done today, a simple recap. We talked about what is a linear equation, how to identify exactly linear equation, what is linear equation. We talked about this. So the second part also with the forms of linear equation, it can be confusing.
Forms of linear equations.
Forms of linear equations.
Yeah.
We talked about this. And the third, we talked about solution. We said that there are many solutions to linear equation as long as it falls, it falls on the line, and the linear equation line or the graph, solution to linear equation. We talked about this. And the graph of linear equation. So the only thing that is pending is simultaneous linear equation. Some people call it a system of equation. I think still now the time, because this runs from 9 to 11, time permits us to continue, but it will be a brief thing, a brief introduction. The next class we can continue from where we will stop today. So graphs of linear equations, simultaneous linear equation. Let's look at a brief introduction to it, and it will also give you some time to look at, you looked at any mathematics textbooks, you will find this here. So simultaneous, or some people call it a system of linear equations, simultaneous linear equation. If you go on to do higher studies in economics or even business, you will see how powerful this simultaneous equation, the economy that we are dealing with, we have 4 sectors, and each of these 4 sectors, they can be represented by equation, linear equation, and you try to solve it. You can use computers at higher level to solve some of these systems of linear equations. So when we talked about the system of, it's very simple. Remember, we said simultaneous. The simultaneous mean that we have more than one linear equation. So in some textbook, you will have systems. So we have more than one equation, but this equation, they must be what? Linear. For example, let me take one typical example of a linear equation. You can just bring any 2 equations. For example, to be more specific, let's look at this. Like 4x plus 3y equals to, let's say, minus 2. And we can also have 8x minus 2y equals to 12. So this is what we call simultaneous linear equation or system of equation. First, this is an equation, and we know that it's linear equation. You look at the powers, none of them is higher than 1, right? So we have another equation. So that's why they call it a system of equation. For this class, maybe we will go up to 2. 3 might come later. So someone can even add more, whereby you have x plus y equals to 8. So then we can have third equation. So how do we solve this kind of system of equation? How do we solve it? How do we graph them? You will understand that, in higher mathematics, sometimes you can even go x, y, and even z. We can even have the third variable, but we will not do that here, because once we have the third variable, remember we have only 2 variables here, x and y. But what if we have a third variable like z? We cannot even visualize it with geometry. That's where you will have metric algebra will comes in. We will look at metric algebra if time permits us in this course, So now, but our focus right now is this. Let's look at 2 system. This is 2 by 2 system. So how do we solve this kind of linear system of equation? This is what we will be tackling in our next class. You can go and think about it. How do we solve this? So you will know that we have seen simultaneous equation. This can be solved graphically. You can use substitution method. Elimination. You can use elimination method. But normally, when we start calculus, especially multivariate calculus, there is another efficient method we call matrix method.
What of Cramer?
Sorry?
Cramer rule.
Cramer comes under this. But for now, this is a basic introductory course. We will take this as optional if time permits us. So what is required of on us is what we are going to look at. To me, this is too basic. This is high school. So we will spend more time using this method. Remember, the goal of this course is not to make you mathematician, but to help you how to use mathematics to solve economics and business problems. This is the goal of this course. Because normally, from my experience, you should have taken even calculus before even coming to this class. So that all what I will do is to do application, but we will find a way to create a balance. There is a gap, and so we will try to fill that gap even in this class. So you can go today and think about this system of equation, how you can solve it. If anyone who wants an advanced materials, I can give it to you, but we will stick with what is required. If we have more time, we can go beyond it. Of course, Cramer rule and identity matrix and others, there are a lot of ways to solve system of linear equation, because it is very powerful. If you go and do further studies, this can represent what? A good market. Every equation you see is representing a market normally. This could be good market. This equation could be financial market. And the third one could be real sector. And the fourth one could be external sector. So we can have 4 equations with 4 variables. And each of the equations can be representing a market within that economy. So we will try to solve that market simultaneously. So what we are doing is building you towards something. So we start basic and we build towards complex structures. So for now, we focus on this. If we understand that, we add more layers to it. So we stopped here for today. I will try to share materials. So for this course, whatever materials, let's keep looking at the WhatsApp group. Any news I will share with you, or I will pass to the class rep, and she will pass it to the whole group. So every information you need regarding this class, it will be shared in the group. So let's keep, let's frequently visit the group and see what is new, what is being shared as well. So on that note, I'm closing the lectures for today, and have a happy weekend, and see you all next class, Saturday, 9 a.m. every Saturday. And have a nice weekend. Thank you all.
Thank you too.
If you have something to say also, you can go on before we before we close the class. If there's any. If there's.
Thank you so much.
All right. You have a nice weekend. Bye-bye, everyone.
You too.